Short and sweet, interpreting the function. First, we're going to look how to interpret the function from a table form. It's all about looking for patterns. We're starting here with an XY table, inputs and outputs, and we need to determine is it linear or exponential, what's the common ratio, or the slope, rate of change, and is it growth or decay. So what I notice here on the input side is that everything is increasing by 1. We know this happens on both exponential and linears, so we don't have enough to make a decision yet. Going over here, getting from 1 to 3 could be a +2, but going from 3 to 9 is not a +2. Okay, so 1 to 3 could also be times 3. 3 to 9 is times 3. Let's check it one more time. 9 times 3 gets me to 27. Since we have multiplication, that tells us that we are dealing with an exponential function because it's a multiply instead of an add or a subtract. Okay, so the idea here of multiply. The common ratio is the number that we're multiplying by. Remember we talked about delta last semester. So our common ratio here is 3. Because 3 is greater than 1, we know that this is a growth function. Because delta is bigger than 1, that gives us growth. Let's do this one more time. Again, I want to come over here and I want to look at my inputs. Again, +1, +1, +1. I want to find that common ratio. So going from 12 to 6 could be -6, but 6 to 3 is -3. Since these are not the same, we're not dealing with linear. We are dealing here with exponential. Going from 12 to 6 can be divide by 2. 6 to 3 is also divide by 2. If we take 3 divided by 2, we will get to 1.5. So our common ratio is, since we divided by 2, that's the same as multiplying by 1/2, and 1/2 is our common ratio. Because our delta is bigger than 0 but less than 1, this represents exponential decay. Again, because 1/2 is less than 1 but greater than 0, that gives us the decay. Finally, if I look at an equation, I need to be able to tell if it's linear or exponential. Both of these formats are for exponentials. So I need to know where that common ratio is. Well, remember that common ratio is given by delta. So common ratio is right here. And in this particular equation, which you'll see more frequently, the common ratio is the B piece. And you will run into both forms of this in this class. Then we need to find that y-intercept. The y-intercept we know is always our starting place. Just like always, f of 0 represents y-intercept. In our expression over here, equation over here, a is our y-intercept. Let's practice that. In this first function over here, we have y equals 3 times 5 to the x power. So the first thing I want to identify is my y-intercept. Well, we know that the delta is always attached to the exponent, so my y-intercept here is 3. Then I need to be able to give that common ratio. what are we going to multiply or divide by each time? In this case, 5, because of the x, is the common ratio. Finally, we have to be able to tell whether this is growth or decay. Well, because 5 is greater than 1, that makes this particular equation a growth function. Let's go to the second one here. First of all, again, I want to identify my y-intercept. The y-intercept is right here on the front end at 7. I want to look for my common ratio. Again, the common ratio is the one that has the exponent. So this is my common ratio at 1/4. Now I have to decide between that growth and decay. And because 1/4 is less than 1 but bigger than 0, this would be an example of a decay function. In conclusion, when you get ready to practice with this, remember what you're looking for in tables is, as you go step by step over here, we're looking for either a multiply or a divide for it to be exponential. We're also looking for the idea of growth or decay. If delta is greater than 1, we have growth. If delta is less than 1 but bigger than 0, we have the decay. And then we also always know that we'll find that y-intercept when the input equals 0. So in this case, this would be my y-intercept. In equation form, remember that y is equal to ab to the x, or y is equal to f of 0 times b to the x.